Hey everybody, this is Rydo and we're back to 7 Billion Humans. This game is very weird, not just because it's a programming game, but in the fact that it's just given me a lot of homework to do, basically. Played a lot more off screen on this than I have practically any other game I've ever played. Like, I, for my channel, I try to do 100% of the footage up front so you can see it so I don't waste my time effectively. And it's just not really doable because it does actually take a decent amount of attention to try and figure out how to program these programs and accomplish the objectives, or just beat the challenge in the first place. And frankly, we ended last recording with me not being able to beat the most recent puzzle, and we're definitely in danger that I would start this episode and spend 2 hours just trying to beat that one puzzle. But that's not the case. So I was able to do quite a few things. So the speed challenge was not done here. This, you go up, you shred all the cubes in each column from order smallest to biggest. The way I did this to speed it up is I added some if statements, which seems like that is definitely the case. The if statements stop. If statements are effectively free as far as the speed metric, but also calculation segments like this seem to be a little bit heavier than walking segments. So there is a puzzle we will see later on where I got significantly faster time just by having the characters walk a lot further than I would have thought that they should have or needed to, instead of having them calculate and know where they're going. But this basically memorizes the smallest number in each column. So each one of these characters is going to walk up here. They're going to find the smallest numbers in each column. When they hit a wall, they're going to say, okay, now go pick up that smallest number and drop it down. And then it saves a little bit of space by having to step up twice here, just to make it more efficient so that they don't go through a bunch of if statements for no real reason. There was no other marker in this pattern that I could have used. In several other puzzles, I could have just looked for an empty spot if all of the data cubes were always going to be full, but many times that is not the case. So it just goes up and down, doing quite a lot of steps. And it really is just a great example of how, like, even though that does seem like that's a really inefficient bit of code, it beats their requirement by 1 second, which is weird. And I definitely feel like some of these solutions under the optionals, when you click this and you see that some of the people have done it considerably faster, I wonder if the way that some of these people got these times is that they were given just a particularly efficient random drop, and that's how they did it. They had one puzzle given to them in it, the randomization of the scenario, that worked really well, and then it failed on many other versions. Yep. And so I must have done the shorter code in the first step. Next we have 38, which this one is really a pain. You gotta find it and shred the smallest data cube. So This was just a full rethink, as it were, to go do what I just did, and go up and then back down, and I still haven't figured out the speed. So these guys go up once, they find the smallest number, then the guy closest to the hole goes to the left, finding the smallest number in the row. There's some fairly large inconsistency here, as it were, and I still would have to figure out some way to remove like 3 seconds. And when you get code that's this tight, it becomes difficult, to say the least, to try and figure out how you could reduce just one small section of stuff. But I definitely, on 36 and 37 and 37, 38, it really these have been very oddly difficult for me. So either there's something, just a basic concept that I'm not understanding, or there's just a huge difficulty spike on these two types of puzzles. This one, again, as far as the number of commands, is just another rethink. Let's see, is this the... Yeah, and I was working on the speed. So 13 steps, which is what is needed, and all this really is just moving the ifs statements around a little bit. And if you move the if statements around enough, yeah, you can probably, for a lot of work, reduce it from 14 steps down to 13 steps. Maybe even get it down to 12 steps. But that still is not a satisfactory solution. And I still have 6 seconds of steps that I need to reduce to try and get all of those done. The next one we got was the speed for 40, and this and the next one are really just kind of inefficient bits of code that we've added a small thing to. Is this 40 or 41 that we're looking at? So the thing to get the speeds is to reduce the number of steps. So what I did is I had them pick one up, go down here first, then go down here first. That way, when these guys decide to go back to the printer and pick up the next cube, they're not going 1, 2, 3, 4, maybe even 5 steps forward. And in this puzzle, they're supposed to each pick up 5 cubes, number them 1 through 5, and then put them down on the ground. So by just keeping everybody close to the printer, they're taking slightly fewer steps, just back and forth. And that's the only thing that changed, and that's the thing that worked. Again, not something that you're gonna feel super happy about, particularly when it's 13 extra things. And this, I believe, I clicked on was, let's see, yeah, I skipped ahead. We did the same thing with this puzzle, except for the only difference here is that this puzzle, you don't have to number the cubes, you just have to put 5 cubes down. So I don't have him walk here, then here. I just have him walk here. I could change the code to accomplish that and make it go a little bit faster. But it's really not worth chasing a dragon, as it were. I'm already below the number of steps that would be needed. Then the next one we have image decryptor, where this one we just put in some super inefficient code with lots of if statements. So they pick up the cubes, whatever number is on the cube, they walk that many spaces to the left, then they jump off into the closest hole. So I just made an if statement to make them go left if it was a 12 or greater, 11 or greater, 10 or greater, 9 or greater, 8 or greater, 7 or greater, 6 or greater, 5 or greater, 4 or greater, 3 or greater, 2 or greater, 1 or greater. And that makes 29 steps, written as if this language did not have loops, or the compiler that's built into this game has no optimization, which nobody would write it that way, because the readability on this is insane. Like, you have to scroll down. Any little mistake anywhere, if I put a greater than sign instead of a lesser than sign, anything like that could be easily lost in a forest of unnecessary words. 29 steps over to 8. But it does give you a super efficient 8 seconds on average instead of 15, which is what they were looking for. See, and that really just goes to show how terrible this system is and what it's actually asking you to try and do. It's not an important goal. It's not a good goal. It's not teaching anything. Also, one of these puzzles I was doing, it was actually raining, and I don't know if that's just because I left the game running or what. And then in this one, I started to get the feeling that speeds more steps is better for calculations, if that makes any sense. So what I mean by that, if I can speak English, is this one is programmed to go all the way to the top, which you would think that would be 10 extra steps, read the number, and then work all the way down, instead of the code that I was trying to write, which was to have this be 81, this be 81 minus 9, this be 72 minus 9, so on and so on and so on, and then divide each of these numbers by 9, and that way you'll know what to subtract each of these numbers from this number to get up there, which would have them take considerably fewer steps while doing a lot more calculations, maybe 20 more calculations. So if we run the numbers here, you have 9 people. 90 steps is better than 20 calculations. And let's just show how this worked. The game didn't really explain that to me, how many steps, physical steps, each character takes and what's that's worth. I did put some optimization there to not have them take that extra step to actually stand on top of the bricks. This is a deceptively difficult puzzle because you do have to get into the memory of each of the characters a different number while having them all do effectively the exact same thing, which is not realistic in programming. I keep saying the same things over and over again, but it really, as my experience as somebody who has programmed, you wouldn't write a program so that 10 different instances all worked. You would just write 10 modifications or variants of the same program. It would be so much easier to do it that way. And yeah, there's other ways you could certainly affect the same outcome without just trying to make something super robust. This one is still driving me crazy as far as a challenge. I've gotten it to work, certainly, but then they want you to have it working at 7 lines of code, which seems basically impossible. Because the only way I can even figure you'd be close to be able to get this to work is if you just write a very sophisticated, very long if statement, which takes up only 1 line to convince them to listen and wait for the tell sound. And speed is in the exact same position where it's just driving me crazy. And then this is the one where we stopped last recording and I got this one to work. Actually, I got this to work twice, but the problem with, I believe, this code is they want, in this instance, they go in a loop forever, but they want you instead to shred 5 documents and only 5 documents. So I could have modified this way, but it's not really necessary because it's overcomplicating it to have them each take a turn. That's not actually a requirement. It's just a requirement that no 2 shredders can run at the same time. So, and the game does not catch after 5 documents have been shredded. So you'd think that would work, but the easier way to do this, I believe, is this one. And you just have them take 5, and then tell the next person to do 5, and then tell the next person to do 5, and then tell the next person to do 5. And I'd highly argue that in that puzzle in particular, they needed to say, give a hint, they don't need to take turns. Taking turns is not necessary or something like that. And you can see, as we are at these final, we're approaching the final section of these puzzles, they're getting difficult enough that I'm not really getting any of the challenges done. And I may very well just cheat it at some point. So I haven't looked at any of these puzzles, so now we can do some new stuff. You've been ranked. The worker all the way to the left is number 1. Sorry, everyone else. The next worker is number 2, and so on. Let's all do a good job. That means you too, number 7, would be number 7, this character. Everyone, please write your assigned numbers on the data cubes next to you and put them back on the floor. Okay. So, label the first data cube with the on the left with a 1, next cube, so and so on down the line. Okay. So I think if I just say if to the left of me is nothing, pick up the data cube and then write to the data cube the value of a memory we'll have to calculate. Memory 1 will be the direction of to the left of us plus 1. Write that down. Well, actually, I think we're going to have to get the value of this. Because once we write it, I think we then need to step forward and drop. I don't know if we even really need a listen or tell in this at all. This might simply just be easy enough to do this. So these guys are kind of wandering around, but they're accomplishing the goal, so we don't have to really worry about it. And it's nice to certainly do a puzzle and kind of just get it on the first try. It kind of sucks that you have commands that you wouldn't use. You certainly could write this a different way, so you could use the listen and tell commands. But yeah, I don't see a reason to rewrite it just because of that. Immediately that does it in 7 or fewer seconds. 7 or fewer commands. So then if you were to copy this and try to do this this way, you probably could reduce this. Else listen for hi and tell everyone hi. Well, actually, just tell that guy hi. And that probably would work fine. Let's see how much that reduced it. There's clearly some more things that need to be done. Get rid of this jump. Let's see. So probably need to put the if command up here and change it like this. If this is not nothing, do that. Otherwise, do all of this. Let's see. See if that works. I do like the general concept of interrupt programming and parallel programming, but very rarely gets used in a lot of programs. Not efficiently, not in a way that people can, even programmers can wrap their brains around. See, and this is really the whole problem, is that this is taking forever because of the calculation. But I have no idea how to change that. Like, it shouldn't change anything if we did this and then said, look this way. Like, that should not speed up the process in any way whatsoever. Yet, in at least one case, it has felt like something like that has changed things. This tells everybody to listen. I mean, you could certainly tell everybody to step forward. You could certainly tell everybody to pick up. You could see, have everybody wait. Then you could calculate. See, why would it change anything if I was to say put mem2 here and have it start with that and do something like that? Let's see. Yeah. Why would that help anything? I don't even think that's gonna work. Pick up. Yeah. We have to calculate that first, or it's not going to be right. They all look left to see if they're the only person on the left. But it's not like they're really walking anywhere. They tap each other on the shoulder. Interesting. They're not walking anywhere. They're not doing any extra calculation. So it really does kind of just feel like some of these puzzles and their challenges are broken. How could you fix 9 lines of code so that it's just considerably more efficient? That it doesn't really make sense. Like they basically are telling me they want me to be twice as fast. And I don't see a way you could be twice as fast. No way. I don't see a way you could identify this one quicker and easier without having all of these run the same code. So if you put this statement this way, get rid of that. This would, the first thing would have everybody listen for high. Otherwise, then you step down, then you pick up, and then you calculate it, and then you write it, and then you drop it. Workers who touch each other's data cube will immediately explode. Let's see if I change this to tell everyone hi. I don't think that's going to really change anything. Yeah, all the numbers would be totally wrong. I could have them not say hi. Like, effectively duplicate all of these actions. But this would be fairly silly, and it really doesn't make sense. More than likely what I need to do is have this one have its own line of code, and then have this one have its own line of code, have this one have its own line of code, and just a extremely long else if statement. That might save you a few steps at the sacrifice of lots of people's sanity, including my own. Well, actually, in this case, I could just have it write 0 and not do the calculation. I don't know if 0 is even the right number. It isn't. Is it? It should be writing 1. And then and see if that worked. It's just going to be frustrating, because that really shouldn't shave off 18 seconds. And it didn't seem like it did. But I don't know any way you do this without running a calculation. That seems impossible. Well, wait a minute. You could have everybody step down, since these don't change any. And number 7 is 43. So I could have it step down. I could then say if the cube you're standing on is 80, write 0, which would be this. And then end. And yeah, there's no way to cheat that. Well, no, maybe there is. You get rid of the listens. Well, maybe you don't get rid of the listens, but maybe you change this quite a bit. Let's see. If to the left of you is not nothing, listen. And then in that instance, you will just write 1. And then if the thing you're standing on is equal to 90, you're just going to then at that point write 2, and then does it make it better to make it an if or an else if? Let's see, if the thing you're standing on is equal to 32, like, this really is an example of where you are making a program to solve a single equation, and there's no value in that. It really doesn't make sense. You might as well just solve the problem the one time that it will be that scenario, and then move on with your life. And that definitely is a problem I've run into where you can very easily waste a lot of time trying to solve a problem with programmatically, when it would have just been easier to do it by hand. I've certainly run into that problem with trying to automate the upload process on YouTube, which is a about 7-minute per video frustrating experience, where it would just be a lot nicer if there was a better experience in the upload process as far as scheduling things and labeling things. Ideally, I would like to see the YouTube upload process be like a film strip. Each film strip is effectively a playlist. You can drag and drop episodes of a series left and right, and when you drag a new uploaded video into a certain film strip, it has default values that lets you fill in the name, the title, and then have variables for like episode number. Also, it should be able to know that that series is supposed to come out on specific days at specific times, so there's really no reason to need to schedule for anything or manually repeat yourself, and that those repetitive actions are the most frustrating part of something like this, where you are just constantly in every video putting the exact same bit of information into the forms. I won't say it's as bad as filling out job applications, but it is dangerously approaching that comparison. So at this point, we're here, and we're going to skip this one. And instead, what I'm going to do is have the next one be 81. And see if this doesn't work. That's going to be incredibly frustrating. And we'll just give up on this. So just writing what is effectively a switch statement, where you could write individual cases. Switch statements do make sense. They don't exist in this programming language really, but they do tend to make some sense in rare occasions. But you're using it definitely wrong if you're using a switch statement in this fashion, or to test a bunch of numbers. Let's see. They definitely are trying to mess me up by having the duplicate numbers. Step forward, pick it up, write it, then drop it. Elsewise, step forward, run the calculation. Drop and say hi. See if that works. Why did that not work? This one went forward, did the right thing, put a 1. It tells this guy hi, and then picks up the item, which I think is the problem. I needed to not have him pick up the item, but if he doesn't pick up the item, he can't ride it. So I need to change it all to my item. And this is why you don't just repeat the same text over and over again, because you will run into problems. So why did this one then stop? Because I need to put the tell command down here. We messed up here and here. Let's see. 9 equals this. 50 should have equaled 5. And then 27 should have equaled 6. And then 43 should be 7. And then 80. Honestly, I think that might just work. Let's go the other way because that would take way too long. Eight, 9, 10. Let's try that again. So if this does speed up the processing, it's speeding up the processing simply because I did all the math for them. And because this doesn't randomize the cubes in any way. Which barely makes this a program at all. Let's see, we've got almost perfect. It's just 27 didn't work. Why did 50 or why did 50 not work? Let's see. Was it 50 that didn't work? Why did 27 not work? Because I made it. I don't know. Like, it should be working, shouldn't it? If my item equals 50, turn it right 5. If my item equals 27, right 6. And yet it's not doing that. Is this just because this game is bugged? And is that the dark secret here? Is that that this game only is programmed well enough to accomplish the solutions the way they see it, and not well enough to do the solutions the way that somebody else might find it? I mean, we really haven't run into this problem before. But I'll be darned if number 1, 2, 3, 4. Yeah, that's number 6. It's not even number 7. 1, 2, 3, 4, 5, 6. If my item equals 27, we'll just change that. Why is... Oh, you know why? Because it does need to be an else it's if command, at least for these, because it's writing a 6 here, and then when it writes a 6 down here, it writes a 10. They threw a little curveball in it. Which certainly just is going to complicate this more. "31 commands instead." Well, this is awkward. Your solution failed more than 50% of random tests. You'll have to take a new approach. Yeah, I've tried to reproduce the conditions with the solution that failed. Try running your program again right now to pay close attention. So apparently the numbers do randomize in the random tests. And thus I've failed completely. So yeah, they definitely did not like that solution. I literally found a solution that only would work that one time. Let's move on to the next one. I don't want to waste a lot of time. "I was driving on the road and I thought, hey, why don't I download? But oh no, there's a toad. Get out of the way, Toad. Go back to your abode. I don't want you to explode. Oops. If only I had slowed. As for the download, I got an error code. What do you think? I'm thinking I'm having some really great poetry inside me to share with the world. What? Your assignment? Okay. I'll just put it over there. You can let me know if you would like me to recite my poem again." The mode code. How many times does each number appear in the grid? There's in the center of the room. How many zeros there? How many ones? How many twos? How many threes? How many fours? Write your answers on the row of 6 data cubes at the bottom of the room and place them back on the floor. The first cube on the left should say how many zeros there are. The next cube should say how many ones, and so on. Do not include the cubes at the bottom of the room in your count. That row is only for results. Okay. Now the thing we don't have as an option is we can't say get the value of something and put in mem1 and then tell mem1 to the other characters. So each of these characters is going to have to do something. Let's see. If we were to set mem1 to 0, okay, and then say if could we cheat a little bit and then pick up the thing in front of us and then write mem1 to it and then calculate mem1 to be the value of what's still left of us, plus 1. I don't know if we even want to pick up at that point, or do we just want to step forward? Step forward. We could also set mem4 as where we are standing at that point also. Step forward, set that, pick up that. Right, that, and then drop that. So we can apparently cheat that. If this equals nothing, doesn't equal nothing, listen for a high command. And we want to do that before we step forward. Let's see. It's not even the right number though. So, with 4 numbers, this might be doable, where we could just go look at all the zeros, find the nearest 0, go to it, pick it up, toss it in the air, toss it in a hole. Although, I don't even know how you toss something in the hole. We could write garbage to it. Possibly. There's 5 numbers. So there is a way to do this. A slightly different way. Let's think about that. Let's see. Dropped in. Alright. If the thing here equals mem1 equals 0, then mem1 equals mem1 plus 1. And this is going to become a very long OR statement. I hope this is the best way to do this, but honestly I'll take any way at all. But we also are going to see a great example of this just being a waste of time. So that's going to get all the zeros. It's going to get all the zeros up in this group. And what's the benefit of that? I could find all the zeros here, and then I could walk over here and go back down this way, go back down this way. Yeah, that's not gonna work. Let's do a quick experiment here. Find the nearest data cube. Step to it. Let's just see where that goes. You know what, just pick it up. And then what can you do? You can pick it up all you want, but then we'd have to add it to memory. Because what I'd like to see is the nearest data cube with a specific value. If I could find all the zeros by default and just walk to it, that would work. But I can't do that. And I can't have all of them looking to the left and all of them looking to the right. I can't have them all going up looking for 1. I mean, because then the count of the number of zeros that this one found, plus the number that were found here, plus the number that was found here, plus the number that was found here, doesn't really make sense. Yeah, I honestly don't think I even have a clue. Let's see if we can get a hint. Apparently you can skip this too. You may have noticed random numbers will be between 0 and 5, so there's 6 distinct possible numbers. You have exactly 6 workers. That's convenient. I don't think so. I don't think that's convenient at all. See, if I set that to 99, what happens there? Yeah, apparently setting that to 99 didn't change anything. Let's see, if the thing is left is not to that, listen, and then jump back that direction. See, it's the value of this plus 1, then the value of this minus 1, which honestly, see how that works. Zero. Zero. Well, we can get that far though. We can get the numbers and then we could do some math later on. But you definitely have a problem with even the way you calculate the math here, is in the fact that you only have 2 variables that you can ever manipulate with one addition, subtraction, division, and multiplication. So And then, yeah, I could pick up everything at that point and then calculate the mem1 to be equal to that. Calculate my item -1. Then write mem1 back and then drop it again, which that seems extremely redundant. Probably not necessary to if I just did something closer to that. So that got us to the numbers. And theoretically, each one of those numbers would be in the brain of each character. Okay, 14 commands to get to that point. Then what? Yeah, that's the question. Let's see. This one, if it was to look for a wall, would go this way. This one, if it was to look for a wall, it'd probably go this way. This one would probably go that way. If we start going to the point where we say if this, we could have everybody step up to the top left, right? And then we could say if this way is a data cube, it's not a data cube, or if this way is not nothing, and this way's not nothing, then walk that way. This just seems like an extremely overcomplicated code already. Like before I've even really done any work. And really, is the rest of the solution just to snake up and down, back and forth, up and down, up and down? Because that's not what we have seen with any of the other instances. Well, what if we went upward, picked up the cubes that fit, and made a column? That might work, but then I'd almost need a point over this direction. And you can't walk to a hole and not jump into it. Let's see. If we were to just step upward, and then we were to say mim2 is going to equal mim2 plus 1 every time we are standing on a cube that is equal to mim1. Then we're going to step up. Then we'll just keep on doing that until there is a wall Let's see if this works. Still doesn't really explain how we're going to get these edges, but I think we could try this. If this isn't a wall. So he saw exactly 1, 5 there. And that was it. So what do we do now? I mean, we could step down and we could write down the number we found. But then how would you use that information in any useful way? Let's see, because this guy found 1, 5 in his column. Good for him. So if he puts down the number 1, and then I tell everybody to now look for something else, how is that going to be helpful? If you picked up all of these and they were 5 1s, that would fail. There's really not enough room here. Yeah, I'm totally lost. Like completely lost. Thank goodness that's an extra puzzle, and it does seem like we could skip it. Let's go to 100 cubes on the floor. Oh no, all of our data got wiped. For real this time. Okay, don't panic. But we have to fix this before anyone finds out. Okay, let's see. We have 100 cubes, so let's just write 100 numbers from 0 to 99 somewhere on the floor. Where? I don't care. 1, 2, 3, blah, 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 99. Just put them anywhere you like. As long as it looks like legitimate data. And hurry up before someone notices. Each of the 100 number cubes between 0 and 99 must be represented on the floor. Their order and location doesn't matter. See, that seems a lot easier. How do we accomplish this? Well, we would have to probably start with just having everybody. Let's just start by having everybody walk to the left. That way they're in a nice little row. That's extra steps, but probably is the best way to do this. And then let's see, we'll even see if this is, let's see what else would we want to do. That is not equal a wall. See, that was weird that half of them did something and half of them didn't. Like, that shows that they're not zeroing out the data. Okay. That's a start. Pick up the thing under you. Write a value. And then we will just calculate the thing above us. And we will add 1 to that. And then we'll write mem1. And then we'll drop. And then we'll tell the person below us, hi. And what we'll do here is if above you equals a wall, we'll just tell everybody to listen for hi. So that should be, don't do that, do that. See how this works. It's really slow. And it's kind of funny that you can only set the values of the things you want to do between 0 and 99, but you can get negative numbers if you subtract. Feels like they should not really let that happen. Okay. Let's see. Else. Listen, then write this, write that, and then drop that, and we'll just set memory to be 0. And then we'll do that. And let's see if that fixes the 0 issue. Yeah, I think that does. Okay. And then after everybody is down here and written their numbers, we should then just have them step to the right and they don't need to listen or wait anymore. They just need to calculate the thing to the left plus 10 and go ahead and pick it up, write it, and drop it, and I don't think we even really need any more code there. We can just kind of let it loop forever, and that probably will let us win. What did I do wrong here? Oh, let's have them step to the right first. This effectively seems like it's a multiplication table challenge, just being done slightly differently. How nice. I'm sure each number really appreciates being part of something, like a grid on the floor. So can we get that down by 2 commands? Probably. Let's see. Probably wouldn't be too hard to do this. Let's see. What we could do maybe is not bother to get all the way to the left first and instead start with 99 here and work our way that way. I don't know. Like that probably would change something. If this is not a wall, listen for high. Could we get rid of this else thing? Probably could get rid of the mem set 0 part because mem it should be 0 anyways. So just getting rid of that one command probably is all that needs to be done. Speed would be the pain. Like, does it benefit you to not walk all the way to the left and instead start at 99? Yeah, that was easy enough to do. Yeah, they want 20 seconds removed. And I think you could do that on the speed. We just need to say if to the right of you is, if you're not standing on a data cube, take a step to the right. Okay. That gets everyone moving. And then that's going to change that to that. And it's going to change that to that. We're going to say if this one is that, then we will calculate this one as -1, and then we need to bring back the else statement in this case, set it to 99, and let's see how that works. 99 minus 10, that's not gonna work. That minus 10, 99, 89, 79, 69. So Then we just need to have this tell the person above. There you go. So that's just going to have them stop. And we probably need an if command so that they don't go in loops over and over again also. Did we make any mistake here? No, I don't think so. Just if this is not equal to if this is equal to a wall. Just go ahead and end. Elsewise. Well, you don't even need an else command there. Let's see if that fixes that. Will the guy stop? 8, 7, 6, 5, 4, 3, 2, 1. Typically, you don't have too many end or return statements in programming either. Probably more programmers should use end or return statements or break or throw statements to exit looping, but a lot of people don't. So I need 8 seconds more. So what do we do to reduce it by 8 more seconds? If this is not on the data cube, step to the right, then pick it up. If below you is a wall, it's not a wall. Elsewise, set this to 99. Yeah, I have a hard time seeing where you save any more steps. Like it seems like everything that is being done needs to be done. So how would you speed this up? I really have no idea. And I really don't feel like this should be that difficult. If I were to hard code this in some way, some more than already I do, I could, for instance, have this guy, instead of writing 99 and then dropping and then telling the person ahead of them and then going into this loop, I could probably hard code him so that he then wrote 98, 89, 79, 69, 59, 49, 39, 29, 19, and 9. I could hard code them to do that, and then I could hard code the next person to just go down that path also, and then we could remove all the calculations. It's not going to be particularly fun to do that. So also write 99 and then drop and then step to the left and then go ahead and just end this, then pick up and then write 89. And then step after we drop. This is just really dumb way to do this. Let's see. Drop, pick up, right, 79. Well, we need to test this before we go any further. Let's see, 69. Let's see. See if that makes it any faster. Yeah, that does seem like that was faster. Except for the problem where I didn't tell the guy above me. You could certainly go down the rabbit hole and write a test condition for starting at 98, starting at 97, and not have any math at all. See, that's 92 seconds, which is now my new fastest. So then write 69. And then drop it. And then step to the left. And then pick it up. And then write 59. I don't get this really. Is this really the way they want you to play? Or am I just being an idiot and missing something very basic? I don't recall the game, the predecessor to this game, being this cryptic. But I also wouldn't really call this like a extra challenge because it's a sequel either. I would just say this is the B tier quality puzzles with a kind of B tier quality idea behind it with parallel processing. And yeah, I'm just not satisfied with this as a challenge. Now, perhaps as I've gotten older as a gamer, I'm more and more less looking for challenges, but But yeah, look what I'm doing. I'm just copying and pasting things. If I could copy and paste things, but I can't. And instead I'm just doing something incredibly repetitive that you would want to basically write a program at this point. And I will fully admit that actually doing a calculation is going to be more processor intensive in an infinitely smaller way compared to just hard coding the answers like I'm doing right now, but it's not a satisfactory reason, or it's not a good enough reason to ever write a code like this. This is just complete ridiculousness. And if that doesn't give us enough, I don't know what would. $69, $59, $49, $29, $10. So that better work for all that effort I put into it. 59 lines of code. And I'm still at 92. This is just BS. It really is. Like, watch how the code runs. This guy moves way faster. He definitely is doing less calculations. So, how are you calculating speed? Is it because these other 9 characters, like, do they at some point have to, like, do they become part of the problem? Is that it? Would I really have to go into this and then try and copy this and rewrite it yet again for every other group? Yeah, that's not satisfactory at all. Let's see what we get with data flowers. Maybe we'll start going in a different direction, because certainly that whole strand has been pretty bad of puzzles, challenges. Not to my liking one bit. Okay, everybody look to the left. Everybody look to the right. Look up, look down, to the left, up and to the right. Ugh, my neck isn't made for looking anywhere but straight ahead. Let's hope you are more agile. I've got a new command. For each direction, or for each directory, I imagine it's direction, use this command to quickly scan the area. Scan each of the 8 tiles around each worker. There's definitely been some puzzles which would have where that would have been very helpful. I suggested they called this command sit and spin, but no one ever listens to my good ideas. See those groups of data cubes, add up the values of the data cubes in each group and write the results in the center of each one. Okay. So this should be fairly easy then. Pick up that, and then if, let's see, for each direction, save that as mem1, that's not going to work yet. If above me and below me is not equal to a data cube, which changes it probably to an OR command. Step up. And we don't have a way of finding the nearest flower. And they got rid of the listen and tell commands for a moment, which is useful. So there's a So wait, let's ask about this. Repeat for each of the 8 directions around the worker. Useful to scan and evaluate your surroundings. The contents of each tile will be around you will be placed into a memory slot, not a direction. If your scanning is empty, your mem slot will store the value nothing. Okay. So I could probably change this code somewhat also, and otherwise I think we're fine, right? mem1 and then drop. See how that works. Step up, find the number, that is not it. We're gonna have to instead calculate a mem2 to be mem2 plus mem1 . So you have actual looping here, an actual for command, but they really aren't doing a good example of a for command or a way you would phrase a for command in most languages, in most ways you'd program. So we did that in 8 or fewer codes, and we got the target once again. Whenever we hit the new branches, of course they give us some easier ones, and there's not even that many puzzles in this branch. Local maximums. Let's all look around the room together. Who's the nicest worker? Who's the most generous? Who's the best looking? Who's most likely to be careless and just dive right into a shredder? Who gives the best gifts? Who eats the loudest at lunch? Yes, I'm sure we're all very good at picking the most extreme things out of a group of things. So each of you please go stand in the middle of a group of data cubes and use your new for each command to identify the largest data cube in that group. Pick it up and shred it. What, me? Yes, I was voted the most likely to leave a trail of broken hearts and document them all in a spreadsheet. So far so good. So no real problem in having everybody step 2 steps to the left. I might as well have just started us with that. And then for each number, if the number in mem1 is less than or equal to a set number, we're going to go ahead and set it to 99. So that's mem2. Let's see, so the largest number actually. So if it's greater than or equal to mem2, then set mem2 to equal to mem1. That means we don't need that command. And then I think it's a simple solution then to just pick up mem2 and give to the nearest shredder, which will set that as mem4. Oops. Feels like there should be some times in which they just tell you no. Like you can't run your code the way it is because you're missing a variable. Getting some more feedback would be fairly helpful. So yeah, once again, we got in the minimal amount of codes and a second faster than what they even expected. Neighborly Sweeper, year 57. Where do all you people go each night? I just assume you all sleep in a pile in the basement. Yes, I see. You have little houses. I assume each house is assembled next to some other number of little houses. And this forms a little neighborhood with sporting events and bake sales and community theater. Yes, I'm glad you have the things to look forward to. The important thing is that we are able to quantify proximity. For each cube below, record how many neighbors it has in the 8 adjacent tiles and write that number on the cube. Yes, I'm sure this will make an excellent antidote for your next neighborhood potluck. Okay. Well, if you're to the left of you is a wall, then step all the way to the right. For after you step to the right for each one of those is a number. Let's see, we need to calculate something here. Mem2 equals mem2 plus 1 if mem1 equals 0, I guess. Seems like that will work. Right. Pick it up, write mem2, drop it, and then set mem2 to 0. And then what do we want to do elsewise? I think it may be fairly easy just to copy everything. It sucks for sure that none of the code whatsoever is going to be able to be reused, but it's not a big enough issue to justify bending over backwards and trying to figure out if there would be some way to not duplicate the code. Of course, inevitably, there will be a challenge to see this through and make it so it doesn't repeat code, because I doubt the optional challenge here. Yeah, 16 or fewer commands. I'm up to 18 right about now. I'm going to end, I think, at 17. So I could get rid of the else statement. But let's just see if this works. Let's start with something. I didn't write the right number. Nor did I put the if statement. So yeah, that was doomed to fail. This isn't right. Why is this not right? This is right, 0, but this should be 1. So that would be going to the left. For each one, if mem1 equals 0, which is the same thing up here, calculate mem2 is mem2 is 0, as it should be. So why did he not work? Picks it up, writes 0, that should be right. He picks the next one up, can't pick anything up, so he moves on. He picks this up, and at this point, he should have okay, I see what I've done. I need to move this under this part. There we go. Of course, messed that up. All these little bugs, all these little tricks, things that definitely could add more frustration to a game that I'd already argue is fairly frustrating. And these loops seem to be causing a problem. And I don't know what else I could do. Let's see. Step if the thing to the right of you equals a wall end. If I could set a variable, certainly, to tell me which way to walk. And then that might get rid of some looping commands. But honestly, I just need to get it to work first before I do anything else. Why is this one wrong? Let's see, set mem2 equals 0. Mem2 equals mem2 plus 1. It's not equal to nothing, I guess would be the more correct way to do this. See if that fixes it. Probably doesn't. If your if command sees data cubes only if they're on the floor, try to query a tile that contains a worker if they're holding a data cube in the air. Your if command will not report that tile as having a cube. That seems like information that could have been useful a long time ago. Let's see, make each data cube display the total number of cubes in the 8 tiles surrounding it. Which of these numbers is not doing that? Like, seriously. I feel like they all are. 8 tiles surrounding it. This one would be actually 9 if it was including the in the count, but then we'd need a whole new count command. This one sees 2, this one sees 2. I mean, seriously, which one is not right? Yeah, I just want to run this again to see if I can pause it and figure it out. This is frustrating to say the least. Alright, let's see. 1, 3, 4, 3, 2, 1, 3, 2, 4. Why is there 4 here? If it's not equal to nothing. If it's equal to a data cube. And I imagine that's worth a try. Okay. So we did that with 24 commands and 55 seconds. So let's see, how would we get rid of commands instead of duplicating this? We want this 16 or fewer commands. Let's see. We could step at the same point. Probably get rid of this and this. And that's 20 commands out of 16 that they want us to do. We could set mim3 to 1. And then what we could do is say if mim3 equals 1, go to the left, elsewise go to the right, and then that should allow us to get rid of effectively all of this. And then it's just a matter of dragging all of this down. And let's see if that still works. Really is just a minor complication. Let's see. So is there something we've messed up here, or do they just need the end? 16 commands. Let's see. If to that equals a wall end, that's 16 commands. Which I think I could do this. If that or that equals a wall. I think at that point it kind of doesn't matter. Yeah. Because they won't run into a wall a second time until they are done. So that's how you do it with 16 commands. At least that's one way to do it with 16 commands. Is the next question, I guess, would be how do you do it to be faster? And I think the easiest way to do that would be to start by stepping here. So if mim3 equals 1, just go ahead and step an extra step in that direction, elsewise step an extra step in that direction, That'll save a little bit of time, not a lot. See, something there just messed up. And I don't know what that would have been. Because that seems like that was just such a slight change that it really shouldn't have changed anything. Would it make any sense at all to hard code the answers into this? I mean, you could certainly do that if you just wanted to gain speed. But that would be a rather dumb system. And it seems like I could probably tell it to look for a blank spot in the 3 spots in front of the place, but then this one would find a blank spot right there and then stop, which wouldn't really be a problem in that scenario. Is there any other scenario where that would even occur? No. So if I go, if this and this and this equals nothing, end. And then if this and this and this all equal nothing, end. And we definitely are in a weird position where we might run into a scenario where the last bit of the game gets ended very early, but I doubt it in this game. I doubt we'll probably go 2 or 3 extra episodes. Or this, or this, or this, or this, I guess. It doesn't make sense to me that these would be ors. It totally feels like these should be ands. If this equals nothing, and this equals nothing, and this equals nothing. They'll step forward. Then they'll step forward a second time. Then this one would be looking here, here, and here. And it finds that that's not the case. But then it looks behind it and it sees something. Okay. So I need to just put that code into that loop and that code into that loop. But these guys did stop. And these guys did stop. Why is that? Because these are ores instead of ands. But see, this code doesn't even work because here's a scenario where it doesn't work. There's a scenario where it doesn't work. So, yeah, that's not even doable. So we got it with a loop. We still are like 42 seconds slower than it should be. And that's just gotta be calculations. So is there some kind of math you could do? Like, this one would see 3. So I go over here, and then does that inform anything whatsoever about that piece? I don't think so. I could say perhaps if this is not a data cube, subtract this by 1, set this to 8, and we could see if the number by default is easier to calculate that way, because there's fewer instances maybe of data cubes not existing. So I'm basically just doing the math in reverse, because you start with 8 and you would just be subtracting instead of adding. And that got us 2 seconds savings. So I guess the next thing you could say is if you're standing on a data cube, then run the calculation and then pick it up and write it and drop it and reset the memory. That probably eliminates a lot of redundancy. Yeah, that did eliminate a ton of redundancy. But now the numbers are all wrong. I bet we can just do that to fix that. And if this doesn't get me, then I imagine we'll be close enough that I can just tell it to stop stepping once it hits a wall, and that'll get us over the finishing line. See, Mem1 This should be mem 2. How does it keep changing back to mem 1? Does seem like the game is either getting a little glitchy or I'm getting a little sleepy with it, and I think probably would say I'm getting a little sleepy with it. I think that is the right answer. I think I just need an exit plan. Let's see. If the thing to the right of you is a wall and or if the thing to the left of you is a wall and you practically have to program with these end commands anyways because it's the only way to trigger an error. Okay. We set this as 8. We set this as 8. Is 8 the wrong number? Do we need to set it as 9? Perhaps. Or maybe we need to set it as 7. That doesn't fully make sense. Seven is one too few. 8 seems like it's the right number. That should be 0, that should be 1, and that's 0. Let's see. I guess maybe there's a whole loop here that needs to happen. What doesn't happen? See, this is a problem with this game not having loops in it. When it says for each dir, is it going through this command multiple times? Or do I need a jump command around it? If it is not equal to a data cube, subtract. Yeah, everything's now trapped in that command. Yeah, it seems like the for each command does a work. Do I need the step command for each data cube? If you're standing on a data cube, do the search. Yeah, that's the most logical way to do that. But what's it missing? Why is there a scenario here where it's not working? So what number here is wrong? This one's touching 4. This one's touching 4. This one's touching 3, 2, 4. Yeah, this one's touching 4. 6. 2, 4, 5, 6. Yeah. 8. Yeah, this one's touching 8. This one's touching 7. This one's, I assume, touching 6. This is 4. This is 5. 5. 3, 1, 0, 2, 5. Yeah. Every single one of them seems to be right. So let's just undo our changes. Set this down to this. Remove that code. That won't work. We'll need to do that. See if this works. Alright, you step to the left. If to the left of you is a wall, you end, or you step to the right. If the right of you is a wall, you end. That shouldn't affect anything at all to have those lines of code in. If you're standing on a data cube, you run the rest of this code. It would be pointless. Let's see. Kind of pointless to pick up and write a memory thing if you're not standing on a data cube. So what's the thing that's messing me up here? Why did this work and then it stopped working? Like, it seriously has something to do with the end command. Well, we got it. I don't know why I got it though. Like, and that's the worst case scenario, is to have code in here and fail. Have it fail and not understand why it's failing. That's just incredibly frustrating, and definitely not empowering as a programming game. And yeah, we end up with, at the end of this recording, I guess I have some more homework to do. Maybe I'll work on these. Maybe I'll look up the answers. Maybe I'll work on these. Maybe I'll look up the answers. Maybe I'll work on this. Maybe I'll look up the answers. I'm not sure we're at a point where I want to do any of that. I may very well not do anything in the next episode. We'll just move forward to this and move forward through all of these. And yeah, it doesn't seem like, from the looks of what the names are of these puzzles, that these are going to be particularly easy. It's kind of weird. We have a decimal counter and a decimal doubler as the last two things, because I feel like we had a counter and a doubler in the first 10 or so puzzles in the first game. We now know what phase 4 is. Also, there's a puzzle. I don't know which one it was that had robots in it. And it was a fairly early puzzle. Data backup day, maybe? Nope. Let's see. Biometric access, maybe? So, yeah, there's an achievement for having these robots that were in this one level. Yeah, there was like a achievement for having them kill you, but I can't even. I wouldn't even be able to find it. Like I'd have to go through all of these and try and figure out like which of these early puzzles it was, and I couldn't even really tell you if it was somewhere close to this or nowhere close to this. It is kind of recognizable as I look at these old puzzles that a lot of these puzzles also only had 3 or 4 people in the group, where the groups are getting just bigger and bigger as we go down this path, and the screens are zooming out more and more. Yeah, I'll never be able to figure this out. Because it could be anyone. It could be any of these, anywhere. It clearly wasn't one that was even a difficult puzzle. I would say it's probably somewhere between 44 and 25, so I guess I could just jump into all of them in this group and find out, and if it turns out that it wasn't in that group, I could work my way backwards further. Like it very well might be between 26 and 10. Like I don't think it's below 10. So yeah, I wish there was a better system to hover over this and get a general visual of what the level looks like and what the challenge is going to be, or just have a pop-up of like what the challenge is. There really is no reason for it to be this way, where you would just have to jump into it. Finally found it. So there's just an achievement for killing your people. So yep. So these little robots will kill your people, and they're only in this one puzzle too. It seems silly, but I guess the general idea was that they didn't want you to step upwards or downwards when solving this puzzle. And so I didn't step upwards and downwards when solving this puzzle. Instead, I just stepped left and right. But it does kind of show that they added these creatures and then didn't use them, these robots, and you could have given us the exact same puzzle with, frankly, half as many people and just have it where they were in a 2-row room where they couldn't walk upwards or downwards. They could have been surrounded by holes, just like every other puzzle. Anyways, that's going to be it for this recording. As always, I ask you to like, share, subscribe, comment, and watch every second of my videos. If you want a friend to follow me on any social media sites, there's a whole bunch of links down below in the description box. And if you want to support me further, there's a link to Patreon, or you can friend me on Steam and gift me a game off my wishlist. Thank you for watching. Have a good evening.